help of CNN. So as of now, the previous session I explained the theory part, that is what is CNN and why we need the architecture of CNN. As of now, CNN consists of four things are important. That is convolution. That is another one is ReLU. Another one is called pooling. At last here now about the full connected layer. So today we're going to see digit recognition. For this one we have to import the data called mnist. So by default it consists of 60,000 images like that. That is images of various handwriting. Digit is like 0 to 9 like that. So for this reason, what I'm going to do, I started the Google Colab and going to import the TensorFlow, Keras and everything. As of now, TensorFlow and Keras, these are the main open source library in the machine learning, where we can utilize for anything. If you want to implement anything, we need support of this one. You can implement. So what I'm going to do, I'm going to load the data set with the help of like this train x comma train y and so on. Then load data set like mnist.load data. Then I'm going to print the train x dot shape followed by test x dot shape. Then for I in range I'm giving, for float plot dot show I'm going to give, and after giving this information we'll can download from the data. That is for sample images showing here. So you can look the screen now. Yeah, some digits showing without much clarity, because as after implementing CNN you may get improvement, that is accuracy. We can improve the accuracy of this digit also, digit recognition. So yeah, so then what I'm going to do is, as of train test and validation only. After that I'm going to call the baseline CNN model for MNICT. For that reason, as usual, I'm calling the from NumPy import. Then I'm writing the from matplot. Then I'm calling the model called sklearn dot model selection. Then I'm going to load and train test data. That is for reason I'm calling the function called define space load data set. Then I'm going to train x comma train y, test x comma xy. As of you know the general thing, 80% training and 20% test will be there any data set. Then I'm going to fix a scale pixels like with the help of function called definition space preparation underscore pixel of train comma test. I'm going to give the plot 30 to 31 and I'm giving the normalization value. Then I'm going to define the CNN model, where I'm giving model equal to sequential and model at add of convolution 2 32 comma 3 comma 3 and so on. So these everything will understand after getting many ideas. So upcoming session, the deep learning session, I'm going to implement so many CNN with a variety of exercise data set like that. In future you may get train of if you have data set you can train CNN easily. So evaluate. So how can you evaluate? We can evaluate using the k-fold cross validation, where I the function called evaluate model data x comma data y and so on. Then folder value I'm giving 5 like that. Then prepare cross validation and followed by fit model. Select the rows for the train and test. Then fit model. Then store the scores. And I'm going to continue the diagnostic learning curves here. So and also call the function called summarize comma diagnostic. Then I'm going to draw the plot subplot of 2 comma 1 comma 1 and so on. Then I'm going to the title as class interface loss and followed by history of loss, validation loss, and classification accuracy, and summarize the model for performance with the help of summarize underscore performance score function. Then I'm going to print the accuracy mean value in the format of percentage 3.c sorry f and so on. Then run. How do you run means we can call the run function called run underscore test underscore harness. Then load data set and follow the same address what we mentioned earlier. Then I'm going to summarize learning curve, summarize diagnosis histories, then scores, run test comma harness. So once generate what happened based on internet speed only it may run. It gives the accuracy of 98, 97, so 98, 98 point or 96 and so on. So it takes some time. So again repeating here, classification it automatic print classification accuracy, validation accuracy, and like this. Keep on generating based on internet speed only. So CNN generally helpful to train the data without manual invention like that, much more invention. If you are training data, you can predict anything based on the training data only. It can predict and validate. At last, with the help of full connected layer, what you can do, you can predict your algorithm and everything. With the help of algorithm, you can predict how much accuracy, whether the classification after classification, whether it's cat or anything. Suppose if you want to differentiate duck and cat, you can go for CNN also. And even whether 7 or 8 number, you can go like this. We have to wait for a few seconds. Yeah, it keep on generating. So simple. There will be easy method. You can directly download like this and utilize this one for implement the mnist dataset for digi recognition like that. Again repeating, there will be around 60,000 images there. You can get anything. Yeah, it start to generate output like 98.5550. So keep on going, generate the accuracy and graph. Generate output, we have to wait for some time. So at last we are printing the test harness also. So at last print the results with accuracy and some cross interfill also. Yeah, start to generate output. So simple and exercise for beginner. The CNN model training, everything is useful for you. You start to generate the output like this. So keep on running. We have to wait for some time to view the output here properly. There will be network issue. Keep on generating the output here. So I'm trying to check the meaning of test harness. So then wait for a few seconds. The output is generate now. So keep on generating. There will be network issue. So run test harness. So output view means we show some graph also. student. So this is how to implement CNN for digit recognition. I hope that you understand the video. Later if you have time you can run and check it out. So once implementation definitely show the at last successfully generate the cross interface loss, classification accuracy, and accuracy saying here mean value 98.668 and standard value of 0.0101 and the value of n squared 5 where we mentioned in the coding also. So I hope that you understand. Thank you for watching the video.